Rakesh here, and I am from IT University, free online university for professionals and students. We are working on a playlist in which I'm making Java and Scala programmers get used to Apache Spark. In our channel, we have lots of playlists according to one's need, but most of at the moment we are targeting big data and big data domain, like how to get it in, how to get Hadoop installed, and how to work on big data technologies like Apache Spark, MapReduce, um, DynamoDB, and HBase, and there are a few more playlists which are very useful for IT professionals. Guys, I'm working on Apache Spark. As part of this video, I'll be covering how to write a MapReduce and how to run a MapReduce program. I hope that we are aware and we know how a MapReduce program works. Little introduction how a MapReduce used to work um, in 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 Hadoop uh, was that every time when we have a input file or input stream, we used to write map class and we used to write reduce class. We used to have uh, combiners in between. Mappers used to process the file and put the records into the local. So every time there's a disk write operation, and then there was a shuffle and sort phase which happens. So I hope you remember that. But in Apache Spark, the main difference between Apache Spark and MapReduce programming of Hadoop is that in Apache Spark, most of the data is in memory. M- Almost the data is in memory. It is processed in memory, and that is the main advantage of having Apache Spark, which makes it really fast. Guys, I have a picture I would like to show you that what is actually difference between Apache Spark and how does it differs from the Hadoop, and what was the reason behind it? What was the reason behind? And we know that Hadoop is really good for batch processing, but the other processing like real time, we have to go to Storm and other stuff. So Apache Spark came up with the one stop solution for every technology. But the difference of the map side and the difference between the reduce side, I'll try to explain it to you. So guys, in Hadoop, particularly, we know that mapper emits output with respect to the key and the value, and that output is written into the local disk, and we know that. And then that output of that mapper is copied from the mappers to reducer, and again it is written to the disk if the buffer memory has exceeded about 80%. Then what do we used to do is that we used to sort that out, and that partitions come into play, and we create a one bundled file to the reducers based on the partitioners, and then we process it. Whereas in Spark, the initial difference was that uh, mapper will emit reducer files, okay, and the data will not be written onto the disk. It will be buffered into the cache. But if the data is really big, then it will be written. Some of the data can be written into the disk, but and the main important thing was the data will be kept into the memory. And suppose I'll in this example they have written as well that suppose there are about 2000 mappers and 6000 reducers, so there will be 12 million records, shuffle files will be there. But that actually was a flaw. Actually it made some issues in the performance, so they came up with another solution. So in the new version of Spark, or the improvement they made was that uh, the processor on which the particular mappers will be working on will emit only one file. So suppose there are about four uh, what do I say processors, and there are about 8 or 9 mappers. Even then, they will give an output of 4 files, and that output will not be combined. That is the main, I think, main improvement which they made. And suppose there are about 6 or 2,000 reducers, and suppose there are 4 cores as given in this picture, so there will be about 8,000 new files will be created and will be given to the reducers, and those files will not be combined. So as I told you that each map task creates as many as spills as number of reducers. That was the earlier initial design. Spark does not merge and partition shuffle spills over one big file. And yeah, that's it. But in the in the improvement phase, what they did was they kept all the things same, but a core will produce so the big difference was a map task which run on a same core will consolidate into one single file. Suppose there are 4 mappers running on a um, one core, or running on a one processor will emit only one file. So example has been given here. So there will be about 24,000 shuffle records instead of 20 the earlier it was shown. So the mapper doesn't make any much difference. Whereas in the reduce phase, as in Hadoop, what we used to do was we used to copy. So there used to be a copy phase which we called as merge phase, and then a bigger file which was a reduce phase in which we used to combine the records according to the partitioned according to their particular key into one file, and then we used to process it. Whereas in Spark, it doesn't do like that. In Spark, mapper pushes to reducers, finally send the file to reducers. So what actually happens is all the data produced by that particular core will be in memory and will be given to the reducers. And if that data does not fit into the memory, then out of memory exception will be raised. So that's the main difference, and I think that is the main difference between a mapper and a reducer uh, um, in Hadoop and in Spark. So guys, I'll demonstrate a simple example in which what I have done is I'll say New York Stock Exchange MapReduce. So this is my object, and I would like to show you where my uh, file is. So here is my file. The first uh, column or the first parameter is the symbol and the date when they were traded, and this is the high, this is the low, this is the open, and this is the closed, and this is the number of volume. So what I'll do is high, low, open, and closed. So suppose guys, and this file is pretty big. You can see the records are from 2009 till 2013, 2014. So this file actually have records of all the 5 years of New York Stock Exchange for all the symbols, or for all the tradable entities. If I'll say so now you can see the size is about is really good, 16 MBs. So guys, what I'll do is you know that when we used to process the same in Hadoop, it used to take a lot of time. I'll not say a lot of time, but it used to take 5-6 minutes because the mappers used to run, and then they used to write onto the disk, and then reducer used to pick them up, and so yeah. So in here, and it used to be a really big code. We used to have a separate mapper classes. We used to have separate reduce classes, and then container class to run them. Here, what I have done is I have a variable conf. I had given the name. I had given a master as local, and I'll be running it on 2 cores. And the memory I had given it as 1 gigs. Here, I have initiated the Spark context, and RDD has been created. New York Stock Exchange data. What I'll do is I'll say val nysc rdd equals to nysc data dot map, and in here what I'll do is I'll say row equals, okay, val columns equals row dot split. Okay, I have split and I'll split it according to this. And then what I'll say is I need columns which is 0, and then columns I'll take 3, and which actually, so the key is the symbol, and the value is the closed amount of that particular uh, closed amount of that uh, mm, particular symbol or particular tradable stock, and it will tell me okay, it has been closed. And then if I'll say reduce, okay, I think this is it. And then probably I'll say reduce reduce by key x comma y gets out to y, then x equals y. Ah, yeah, I think that's it. And then what I need to do is uh, dot collect. Yes, I have collect dot for each. Yes, and print ln. So guys, this is it. Have you seen the magic? That all the mapper code and the reducer code has been written here. Now I'll run this, and now I'll like to show you. To run this, what I'll do is I'll go to run configurations. In my configurations, I had given the NISC mapper, and in arguments, I had given the file name. So I hope this is clear, right? So now I'll run it as Scala application. Okay, it is running. Oh, this is it. Have you seen that it has printed the data? Now, if you could see, it has given me the data that for this particular stock FSL, the max which has gone is 9.99 in last 4 years. So have you seen the speed in which it has processed the data, because it was all in memory? Whereas if I would have performed the same on Hadoop, it would have given me a performance based, like I could have seen it is throwing a mapper task and then a processor task. But for me, it is very seamlessly, and it has great. It has executed this, and I'm really happy with this. I think this is it. I'll probably create a new playlist in which I'll explain you what the DAG scheduler is and how the memory is being stored and the other details. But I'll suggest you to also to go through it in detail. Okay, I think that is it. Thank you guys. I'll recommend you, if you have not seen or if you have not seen the previous videos, just go through the playlists which my mentor Durga uh, has actually given a lot of his knowledge in these, and because these playlists actually cost a lot if you go for online training. I cleared my Hadoop certification by watching his videos and by practicing in home. So I guys, thank you very much.